Hello, Mindsetters. Now it's time for grade 11s, and we're doing functions. I'm not alone, as you can see. My name is Abraham, and I'm joined by Natasha. How are you, Natasha?
I'm very well, thank you, and it's really nice to be with you guys once again, grade 11s, doing functions, as Abraham said.
Can you feel the energy and the vibe?
Of course, always.
Are you revived?
I'm revived. I didn't go that far away, though. It's only been a week.
All right, well, take your position and let me speak to my Mindsetters. Well, grade 10s, there are simple things that I need to tell you. Firstly, is that we're going to be having a great session. You better take out your notepads and pens, and we get to it and start learning. And secondly, there's a Future Stars competition that you can enter for. The details are right on the page. I'll be posting them soon also. What you need to do is enter for the competition and get your friends to vote for you, and other Mindsetters can support you, also vote for you, and that's how you can stand a chance of winning some great and really cool prizes. Otherwise, Future Stars competition is there to inspire you as a young person, you sitting there at home between the ages of 16 and 21, in helping you believe in yourself and also empower you in learning about the power that education has on your own life. And now, let me also tell you that this show, it's proudly sponsored by Macmillan. We're going to be learning a lot, as you better be chatting with me on facebook.com/LearnExtra. And also on Twitter, you can tweet me at LearnExtra. Otherwise, get your notes for the show on learnextra.co.za. A big shout out to you, grade 11s, watching right now, as Natasha is taking it away. Ready? Let's go.
All right, thank you so much, Abraham. Okay, guys, so remember, this is a continuation of the functions lesson that we started last Monday. So if you're wondering why aren't we doing parabolas and hyperbole in this lesson, it's because we did it last week. If you missed that lesson, remember, all these lessons are on the website, so you can just go back and quickly revise those concepts. I'm going to do a very quick revision about the concepts that we did last week, but our main focus for today's lesson is going to be looking at how the values of P and Q affect the exponential graph. The defining equation for the exponential graph, y is equal to a times b to the power x plus p plus q. This looks slightly different from grade 10, obviously because of the addition of that x plus p in your power. All right, we're also going to look at finding the equations of graphs today, and then we're going to do a question on graph interpretation. All right, so we're not going to waste any time. We're going to get stuck into the lesson because we've got so much to cover. You know, functions is such a big section in grade 11 and grade 12. So grade 12s, if you are just, you know, browsing through the screens and checking what's on TV and waiting for grade 12 to come, you need to be paying attention to this lesson as well, because this functions comes up again in grade 12, and you know, it's a big chunk of your marks both in grade 11 and grade 12. So it's a nice revision session for grade 12s as well. All right, so as I said, we're going to do a quick recap of what we looked at last week. Okay, and this is relevant for all functions. Okay, so for all functions, the following points are true. Okay, if Q is greater than naught, so if we're looking at the value of Q and the effect that it has on the different graphs, Q will mean that you're going to have a vertical shift. Okay, so it's going to be a vertical movement. If Q is positive, then your graph is going to move vertically upwards by Q units. Okay, so it's going to move up by Q units. If Q is less than naught, so if Q is negative, then the graph is going to move downwards by Q units. Okay, so remember, the value of Q affects the vertical movement of the graph. The value of P, as we discussed last week, and we're going to look at again this week, the value of P will affect the horizontal movement of the graph. All right, so what happens? Well, if P is greater than naught, so if P is positive, then the graph is going to shift horizontally to the left. Okay, so it's going to do the opposite thing. If P is positive, your graph moves to the left. And then if P is negative, your graph will move to the right. Okay, guys, and remember, that holds for all the different functions that we look at. But specifically today, we're going to tackle the exponential function, which is y is equal to a times b to the power of x plus p plus q. Okay. So as I said, with the graphs last week, we did the parabolas and the hyperbole. The effect of Q and P is exactly the same. Okay, some of the things you need to remember about exponential graphs. There is a horizontal asymptote at y is equal to q. Okay, so horizontal asymptote at y is equal to q. Now remember, with the hyperbola you had two asymptotes, but with the exponential graph we've only got one asymptote at y is equal to q. Now if this number in front of your exponential function, if a is positive, then your graph will be decreasing if this b is a fraction. So if b is a fraction between 0 and 1 and a is positive, you're going to have a decreasing graph. It's going to look like that. All right? And then if b is greater than 1 and a is positive, you're going to have an increasing function. Okay, that's important. You need to know how the values of a and b affect the shape of the graph. And in fact, it's one of the first things you should be looking at is the shape before you sketch the graphs. Okay. Now that was if a is positive. If a is negative, and we're looking at a fractional value for b, so that is numbers between 0 and 1, then your graph is actually going to reflect about the x-axis, because remember, a is negative, so you're going to get a reflection in the x-axis, and you'll now get an increasing function. All right? And then if a is negative, and we're looking at b being greater than 1, then your graph still is going to reflect about the x-axis, but it becomes a decreasing function. All right? Okay, so just some of the points you need to remember about the shape of the graph. But obviously the best way to do these kind of questions is to look at an example. So let's get stuck in with our very first example. So here we asked to sketch the graph. Y is equal to 3 times 3 to the power x minus 2 plus 1. First thing we notice, guys, a is 3. So a is greater than 0. B is 3. So b is greater than 1. So therefore, if we go back up here, remember what I said to you? If a is greater than 0 and b is greater than 1, we have an increasing function. So our graph is going to look like that. So we already know the shape of the graph before doing anything. Okay, so as we said, b is greater than 1, therefore we have an increasing function. The next thing we can do from this equation very easily is write down our horizontal asymptote. So remember, your horizontal asymptote is y is equal to q. And in this case, q has a value of 1. So therefore, y is equal to 1 would be the horizontal asymptote. Okay. X-intercept. Just like in any other graph, if you want to find the x-intercept, you let y be equal to 0. So let's do that. So I've got 3 times 3 to the power of x minus 2 plus 1 is equal to 0. Remember, I'm looking for the x-intercept, so y is 0. All right. First thing we do, let's take the minus 1 over. So we're going to get 3 times 3 to the power of x minus 2 is equal to negative 1. Straight away, you can actually stop because you can't go further. But if you would like to go one step further, just so that you see it more clearly, we can divide through by the 3. So we get 3 to the power x minus 2 is negative 1 over 3. All right, guys, now there is absolutely no way you can make this base. Remember from your exponential equations, you can't make this base and this base the same, because even though a third is 3 to the negative 1, this negative in front straight away means you're dealing with different bases. So therefore, there's no solution. So therefore, what does that mean in terms of the graph? We were looking for x-intercepts, so that means there are no x-intercepts. All right. Okay, next thing, let's find the y-intercept. How do we do that? We let x be 0. Okay, so in my graph, y is equal to 3 times 3 to the power x minus 2 plus 1. All I'm going to do is let this x be 0. So I get 3 times 3 to the power of 0 minus 2. So 3 to the negative 2, because 0 minus 2 is just negative 2. So that's going to give me 3 times 3 to the negative 2. Remember your exponents, very, very important section for grade 11 and grade 12. So it's going to be 3 times 1 over 3 squared plus 1. So this is going to be 3 times 1 over 9 plus 1. So 3 times 1 over 9 is a third plus 1 is 1 and a third. Okay, so therefore we've got no x-intercepts and we've got a y-intercept at the point 1 and a third. Okay, so guys, I've shown you what have we done. We've looked at the defining equation. That told us what the shape of the graph was going to be like. We saw that this is going to be an increasing function. Okay, once we got the shape, we then worked out that the y-intercept, straight from this equation, we got the y-intercept, not the y-intercept, the y-asymptote was y is equal to 1. So it was just that horizontal line at y is equal to 1. Remember your asymptote, it is a line where your function will not be defined. So the function will never cross the asymptote. Okay, that's what an asymptote does to the function. It makes everything along that line undefined. So therefore, your function is undefined at the asymptotes. We then worked out the x and the y intercepts, and we're ready to plot the graph. But what I want to show you, just as an aside, before we plot the graph, is that you can actually, and I know a lot of you love using your calculators, so you can work out a table, okay? And that's this little section here. You can work out the table for these graphs by using your calculator. Okay, what you'll do is you will type the function in and you will then get a table of points. I'm going to quickly show you how you can do this on your calculator. All right. Hopefully you can all see the calculator clearly. So the first thing you do, guys, is you want to use mode 3. So you hit mode and we're looking at 3. We want the table and you see it comes up as f of x is equal to. So it's in the form where we can write a function, right? So it's going to be 3 and then we've got times 3 and it's to the power of x minus 2. So we hit the power button. And very important at this point, we need to use brackets because we want both the x and the minus 2 to be the power of your 3. Okay, how do you get to the x? You go alpha and then x, and then we've got minus 2. We then close our brackets and we enter plus 1. Okay, so if you do everything correctly, your function will come up on your screen. You then hit equals and it will say start where. So we're going to start from minus 1 and we're going to go up to 1. Okay, you go equal again. It says steps going up in ones, yes. And you press equals. And as you can see, guys, on your screen, you've now got a table. Okay, at 1 you can see you've got minus 1. At minus 1, sorry, there we go. At minus 1, your function value is 1, 1, 1. If we go down again at 0, your function value 1, 3, 3, which makes sense. That's the y-intercept. Okay, at the point 1, your function value is 2. So you can use that table and then plot the points and draw your graph straight from that table. Obviously, you still have to know what the asymptote in that is. Okay, so feel free to use that method of using your calculator. Okay, I'm going to go ahead and draw the graph. Remember, we had an asymptote at y is equal to 1. So that was the point 1 on the y-axis. And we had a y-intercept of 0 and 1, 3, and we also had no x-intercepts. So our graph is going to look like so. All right, so this is the point. If you were putting points down, that would be the point 0 and 1 and a third. On your graph, this is the asymptote, y is equal to 2, and that's the equation of your That's the graph of your function 3 times 3 to the power x minus 2 plus 1. Okay, and you would get exactly the same graph, exactly the same shape, if you plotted the points from your table and then just plotted the points and from your table in your calculator, join all the points up and you'll get exactly the same graph. All right, and I think at this point might be a good time to cross over to Abraham, see if there's any questions and see if we need to take a break.
Well said. On that note, mindsetters, I'm still chatting with you on the page. I'm enjoying the vibe that I'm seeing, Natasha. I've got guys saying, we as the pre-matrix are enjoying the show. I like that. Your Neos and Sabelos. Guys, we'll check you out right after the break. Do not move. Welcome back, pre-matriculants, as they are saying over the page. My name is Abraham, and you're still with me and Natasha, learning a lot about functions. Over the page, there's some great excitement too. Mindsetters, if you're on our Facebook page, by now you should be knowing it. It is facebook.com/learnextra. Tweet me. I'll be reading a couple of tweets that I have later on at Learn Extra. Also download your notes for free on learnextra.co.za/live. And also I've posted on the page some very trick facts that I have, which says 3 out of 2 people are having troubles with fractions. Are you one of them? Someone also commented saying, I think you, Abraham, are one of them. Natasha, are you one of them?
No, but I think you definitely are one of them.
No. Okay, great exposure. I'll get you. But let's continue on fractions before I expose you.
All right, guys. So we're back from the break. Now, remember what we were talking about before the break. We were looking at how the value p affects the values of p and q affects your exponential graph, and then we drew an exponential graph, and I showed you that you can actually use your calculator to work out a table of values that will help you to plot the points, and you can draw your hyperbola, or actually any of your functions. If you know how to use the function on your, well, it's actually called a function, but I mean, if you know how to use the fx function on your calculator, then you can use that to draw your parabolas and whatever else, your hyperbole and the rest of them. Okay, so we've done that. We've looked at p and q. We're now going to look at finding the equation. All right, so you know there are different methods to find the equation for different graphs. And guys, what I'm going to do is I'm going to give you a few pointers for the parabola and the hyperbole, and then we're going to look at an equation where we've got to find the equation of an exponential graph. But remember, these are not hard and fast rules. Well, they actually are. If you've given these specific cases, you can do what I'm showing you to do here. But remember, they can vary the questions. It doesn't have to be in this format. So you need to understand your functions very, very well so that you can find the equations, you know, just on a whole lot of different scenarios that we could throw at you. Okay, so the ones I'm going to look at for the parabola, firstly, you can be given the turning points of the parabola and some other point. So say, for example, we've got a graph, a happy face graph, a positive graph, so a is greater than 0. So we give you this point p and q, and then we'll give you some coordinates on the graph x and y. Okay, so we'll give you those values. So if you've got the turning point and another point, then you're obviously going to use the defining equation, y is equal to a times x plus p squared plus q. All right, and what you're going to do is substitute the coordinates of the turning point in for p and q. All right, so you'll put the values for p and q in. Remember to be very careful with your sign of p. And then you would then, once you've put p and q in, you're going to have another unknown. You're going to not know what a is. So how would you find a? You would substitute the coordinates of the other point that's given to you on the graph. Okay, so if you've got turning point and another point, you'll substitute the turning point, substitute your other coordinates, and then solve for a. All right, so that's case 1. Then still with the parabola, the other thing is we could give you the x-intercepts and some other points. Okay, so if we've got some parabola like that, they'll give you this x-intercepts and that x-intercept, so we can say x1 and x2 is given, and they'll give you a point on the graph xy. So they give you some random points and they give you the x-intercepts. the formula you use there to find the equation of your parabola is y is equal to a times x minus x1 times x minus x2. The x1 and the x2 are your x-intercepts. Okay, so what will you do? You'll substitute the value for x1, substitute the value for x2, again being very careful with your signs. And then you're going to find that, okay, I still don't know what the value of a is, so you will find a by substituting the coordinates of the other point. This xy, the other point that they've given to you, you'll substitute that value in and then solve for a. All right, so those are the two different methods. If you're given x-intercepts and another point, and if you're given the turning point and another point, that's the method you can use to find the equation for a parabola. All right, hope you're all with me. We'll move on to our hyperbola. Now, the position of the asymptotes for the hyperbola obviously will give you p and q. Remember, the defining equation is y is equal to a over x plus p plus q. So if they've drawn a graph and they've given you the asymptotes, then obviously that would be the value of p and q, right? And to find the value of a, if you've got p and q, all you'll do is you substitute any other point that's given to you on the graph. So generally, if they're going to give you the asymptotes of the hyperbola, they'll also give you another point in the graph so that you can substitute that value in and then solve for the value of a. All right. Okay, so that's just some of the methods that you can use to find the equations of the parabola and the hyperbola. Now, when it comes to exponential graphs, they can give you a whole number of different scenarios. So I'm not going to do one set method, but generally, because remember, the defining equation for a for an exponential graph is y is equal to a times b. See, there's quite a few unknowns here, hey? Look, q is unknown, p is unknown, b is unknown, and a is unknown. And it is very, very unlikely, in fact, it probably will never happen where you would be given all 4 unknown values to find. Okay, so generally you'd have to find 3 or more of those unknown coefficients in this equation. Okay, so we're going to look at an example where they give you the value of a, and you've got to find the value for b, p, and q. All right. Guys, if you're following in the textbook, this is coming from Keeping Maths Simple, grade 11 learner's book, page 165, and this is exercise 5.19. We're looking at number 6. Okay, so that's if you've got the book, you can follow along there. All right, we are asked to find the equation of the graph y is equal to b to the power x plus p plus q. Hopefully you can all see that the value of a is 1. Okay, there's just a 1 here in front of the b. There's no other, there's no need to find the value for a because it is given. Okay, so we can forget about the a value. We've already got it. Okay, hopefully you all agree that the next easiest value to fill in is the value of the asymptote, so the value of q. And if you look at the graph, you see that the asymptote is at that point minus 4. So therefore, the equation of the asymptote is y is equal to negative 4. Okay, that's your horizontal asymptote at minus 4. So it's quite easy to see what the value of q is. So our equation now goes like this. Y is equal to b times x, b to the power x plus p minus 4, because we now know what the value of q is, so we can simply fill it in. Okay, so your equation, there's now less unknowns. Now we only need to find the value of p and b. All right, so we know that q is negative 4. Okay, how do we find the value of p and b? If you look at the graph, you'll see that they've given you 2 coordinates. They've given you the points 2 and 4, and then they've also given you the point -1 and -3. So those are 2 points, let's just call them A and B. They've given you 2 points, A and B, that lie on the exponential graph. So if you've got 2 coordinates, now think about it, you've got 2 coordinates and you've got 2 unknowns. How are you going to solve for the unknowns? Okay, hopefully you all remember your grade 10 work really well, and you would have revised it at the beginning of this year as well. It's called simultaneous equations. Okay, so we've got 2 coordinates, we've got 2 unknowns, so therefore we can use those coordinates to help us make 2 equations and solve simultaneously. Or, as you'll see in this case, what's going to be easier is to use one of the coordinates and see if we can work out either the P or the B and then substitute that back in. Okay, so we can use the method of substitution with the simultaneous equations. All right, so I'm going to use the point -1 and -3, and I'm going to substitute it into this equation that we've now changed because we know what the value of Q is. All right, so I substitute it in. So y is -3, x is -1. So I'm going to get -3 in place of y is equal to b to the power of x, and we know x is -1, plus p -4. All right, guys, hopefully you can all see what I've done there. It's nothing very dramatic. All I've done is I've just substituted the coordinates in to our equation. Okay, and I'm going to try and solve for the value of b. All right, so we take the 4 over to the left-hand side, becomes +4 -3, which is 1, is equal to b to the power of -1 plus p. All right, how do we solve this? All right, and I wish that I actually had someone screaming here, screaming out the answer. Hopefully you're screaming out the answer at Abram. But how do you solve this? You've got b to the power -1 plus p is equal to 1. How do you solve this? All right, the only way to solve this is to use exponential equations. All right, how do we use the exponential equations? Well, we can rewrite 1 as b to the power of 0. Okay, because remember, where you are solving for an exponent, where you're solving for an exponent, you need to have the same bases. All right, so I can rewrite 1 as b to the power of 0. Now, since the bases are the same, I can equate the powers. So therefore, 0 is equal to -1 plus p. Therefore, taking the -1 over, I'll get p is equal to +1. All right. Okay, so we've got p is equal to +1 by substituting the coordinates of -1 and -3 in place of x and y. So now our equation changes slightly again. It's now going to become y is equal to b is still unknown, to the power x, and p is 1, so it's going to be x plus 1, and then minus q, which was -4. Okay, so our equation, as you can see, has evolved. Now we only have one unknown. Okay, you can see that the only unknown is the value of b. How do we find the value of b? You go back to your graph, and you see that they've given you the coordinates of another point on the graph. They've given you the coordinates 2 and 4. So you can use these coordinates and substitute the value for x as 2, the value of y as 4, and then solve for b. So we're going to use 2 and 4, put it into that equation and solve for b. So this is what it's going to look like. We're going to say, okay, y is 4 times is equal to b to the power of x. X is 2 plus 1 minus 4. So we get 4 is equal to b to the power of 3. 2 plus 1, 3 minus 4. Therefore, taking the minus 4 over to the left-hand side, we'll get 4 plus 4, which is 8, is equal to b cubed. All right? To get rid of that power of 3, I can then cube root both sides. The cube root of 8 is 2. So therefore, we get b is equal to 2. Okay, so now we have all our variables. We know that b is 2. We've worked out the value for p. We've got the value of q. So now we can write the defining equation for this exponential graph that they've sketched for us as y is equal to 2 to the power of x. Remember, what was the value of p? It was 1. 2 to the power x plus 1 minus 4. Okay. And that is the equation of this graph. Guys, what you can do, and I always like to do a quick check. Remember, we have the coordinate 2 and 4 on the graph. You can quickly just substitute the x value of 2 and see if you get the y value of 4 to make sure that your equation is right. All right? So if x is 2, I'm going to get 2 to the power of 2 plus 1, which is 3. So it's 2 cubed minus 4. 8 minus 4 is 4. All right, so you can just quickly check one of the coordinates to make sure that you've got the right equation. All right, so we've done quite a bit today, and I think it might be time for a break before we look at graph interpretation.
Oh yes, Natasha, on that note, I'm loving what I'm seeing on the page. Their mindsets helping one another, and also a very interesting discussion that I found on the page from Supernovias and Debucho saying, how can I have maths as part of my favorite subjects? That is a question that was posed by Supernovias. I'll give you the tips that Debucho gave us, and I hope that Natasha also will give us some few tips after the break. So do not move, stay tuned, see you right after this. Welcome back, Mindsetters, and as promised you that we'll be chatting a bit just before we get starting to your lesson about why you should make mathematics your favorite subject, or how can you make it one of your favorite subjects. The tips that we have from the Mindsetters are: 1, you need to love your teacher. That's the most important thing. And secondly, practice and practice. That's how you're going to keep it on the roll, and that's how you're going to understand. And lastly, throwing it to you, Natasha, Neo says, why are we learning functions? Actually, how will functions help us in the future?
All right, well, functions are a huge use section, not only in your exam, but in everyday life. But I just want to answer, also throw my 2 cents in there about how you can make maths one of your favorite subjects. You have to ask lots and lots of questions. Maths is one of those subjects where if you just stay lost and you just think, okay, someone else is going to ask the question, it's not going to happen. If you are stuck, you need to ask questions, get them sorted out. And I mean, once you understand the section, it's really, really very, very simple. Okay, and also it's really, and I know I say this all the time, maths is like golf. The more you practice, the luckier you'll get in your exam. So the more of the same questions you do over and over and over again, they're going to eventually just seem like, oh, I've seen this 100 times. So that's you know, a nice way to make maths your favorite subject. Just practice, practice, practice. All right, then touching on why do we study functions. Now guys, there's so many real life applications of functions, and you know, just think about the parabola, which you see every day. Just look around the room and see if you have any kind of parabola shapes in your room. Okay? Also, think about our Moses Mabhida Stadium in Durban. If you look at the arc that goes around on the outside, you know, you guys that are in KZN, maybe you've been there, or you know, you other guys, you might have seen pictures, but there's sort of this big kind of arc going around the dome. That arc is actually a parabola. So it doesn't matter how many years of engineering and whatever the technicians did, and the engineers and the architects to be able to make that stadium, they still would have needed to know what the turning point was. They still would have needed to know what the maximum height was. So there you go, functions in real life. But it's actually a good activity. Go around your school, go around your classrooms, just look around at home. Where do you see functions? I mean, you know, look for the shapes. Look for the parabola is an easy one. Hyperbole, slightly harder, but parabola you see every day in real life. Anything else, Abram?
Well said. On that note, I'll keep getting to you and giving you some of the comments as we continue.
All right, great. Okay, guys. So this is our last question for today's lesson on functions. So far we've looked at how the value of p and q affect your exponential graph. We drew an exponential graph, and then we also found the equation of an exponential graph and touched on how you can find equations of parabola and hyperbole depending on what information you're given. So for the last question we're going to look at graph interpretation, and again I reiterate, grade 12s, this is so important. Functions are a huge chunk of your marks at the end of the year, and it doesn't have to be a difficult section. All you've got to do is practice. Okay, so this comes from, once again, Keeping Maths Simple, and this is grade 11 learner's book, page 177, exercise 5.21, and we're looking at number 6. Okay. You might see a few blocks here. Just ignore those little blocks. They don't really affect your equations. Our equations on the diagram represents the graph of f of x is equal to minus x minus 2 squared plus 4, and g of x is equal to 2 to the power x plus 1 minus 4. Okay, let's have a look at the graphs. So you can see they've given you the graph of f, which is the parabola, right? So that's our graph f in orange. And then in white, we've got the exponential graph g. Okay, so you can see they're intersecting. We've got a whole lot of coordinates and points on the graph and so on. And the first question says, calculate the following. Okay, and it wants us to find the length of OE. Okay, so that's from there to there. Before we look at that question, remember, let's just analyze what we've been given. You've got the function, the parabola, minus x minus 2 squared plus 4. Hopefully you guys realize, and I mean, it's good to have an understanding of what you're looking at. If we've got a negative graph, a negative a value, we're going to have a sad graph, okay? Important thing about the value of a being negative is that you have a maximum turning point. Okay, remember? Negative because it has maximum problems. Okay, so important point. Then if you look at your exponential graph, what do we notice? The value of a is 1. B is a value that's greater than 1. B is equal to 2. So therefore you have an increasing graph. And it's important to analyze these points because even though, if you look at the questions, we just asked to find length, there could quite easily have been a question here saying, does the parabola have a maximum or minimum turning point? So you would need to be able to understand that without even looking at the graph. You can look at the equation, you can see, okay, a is negative, so therefore I've got a maximum turning point. We could also say, is the exponential graph increasing or decreasing? So it's important concepts that you need to understand before you tackle graph interpretation. Okay, let's get stuck in with the question. The first one is to find the length from O to E. Okay, so if you look at this distance, OE, okay, so we're going from the origin to that point E there. Right? You will notice that E is the x-intercept of the parabola, and O is at the origin, and it also happens to be another x-intercept of the parabola. So if I want the distance OE, what I need to find is the coordinates of E, and then all I need to do, because we've got a horizontal distance on the x-axis, once I've got the x coordinate, all I'm going to do is subtract the two x coordinates to find the distance from O to E. So the x coordinate at point O and then the x coordinate at point E. How do we do it? So this is part A. So we're going to use f of x is equal to negative, let's just get that equation back. It was negative x minus 2 squared plus 4. All right. How do you find x-intercepts? To find x-intercepts, remember, we say let y be equal to 0. Okay, so we're going to get negative x minus 2 squared plus 4 is equal to 0. And remember, we solve for x because we want the x-intercept. So we get negative x minus 2 squared is equal to negative 4. Guys, I'm going to do it. I mean, you can times your brackets out in that. I'm going to do it in a slightly different way. We divide through by the negative 1, so we get x minus 2 squared is equal to positive 4. So at this point, you can times this bracket x minus 2 squared, bring everything to one side, and then factorize a trinomial. But what I'm going to do is, because I've got two perfect squares, I'm going to square root both sides. So therefore, I'll get x minus 2 is equal to, remember when you take the square root, plus or minus 2. So therefore, we'll have x minus 2 is equal to positive 2, or x minus 2 is equal to negative 2. All right, so the first one gives me x is equal to 4, and then the second equation gives me x is equal to 0, which makes sense because remember when I showed you the graph, one of the x-intercepts was at the origin, so it was the point 0, 0. Okay, which means that this must be the coordinates of point E. E must be the point 4, 0. So if you want the distance from O to E, we know that the x value at point E is 4. We know that the x value at point, well, at the origin is 0, 0. So all I'm going to do is subtract. I'm going to say 4 minus 0, and I'm going to get that the distance from O to E is 4 units. All right. So OE is equal to 4 units. Okay, and guys, this is a typical question. You know, if you've got points on the x-axis, we often ask you to find the distance between the 2 points. If you're looking at the x-axis, it means you're looking at your x-intercepts. All right, let's move on to the next one. Here we are asked to find the distance O to D. Okay, so O to D, let's see, is it a point on the parabola or the exponential graph? And you see that D is actually a point on the exponential graph. Specifically, it's the y-intercept. So it's the point where the x value is 0. So if I want the length from O to D, which is that vertical distance, all I need to do is to find the y value at point D, and then I'll get the distance from O to D by saying the y coordinate at point D minus the y value at the origin, which is 0, and we'll get that distance. All right, so here we're looking at the exponential graph. Okay, your equation here, g of x is equal to 2 to the power x plus 1 minus 4. Okay, so g of x is equal to 2 to the power x plus 1 minus 4. We're looking for the y-intercept. So we're looking for when x is equal to 0. We let x equal 0. We get 2 to the power 0 plus 1 minus 4. So that's 2 to the power 1, because 0 plus 1 is just 1. So we get 2 minus 4, which is negative 2. So therefore, the coordinates at point D are 0 and negative 2. So we know that this is the point 0 and negative 2. If I want to find the distance from O to D, I'm going to say the y-coordinate at the origin minus the y-coordinate at point D. So I'm going to say 0 minus 2, and we get minus times a minus is a plus, so we get positive 2. So therefore, the distance from O to D is 2 units. So OD is equal to 2 units. Okay, before we carry on, I quickly want to check if anyone has any questions with Abraham.
Yes, I do have a question. It is from Gugzin. It says, as you said that 1 can be written and B can be written, as you said that 1 can be written and B to the power of 0 and our basis must be the same. if I had another letter on the other side, would I still be using B, or is it even possible to have any other letter other than B?
Okay, so this is a question not about what we're doing now, and I was
Yes.
hoping we were going to tackle what we were doing now. This is a question about
What
the
we did
previous one we
earlier on.
did before. So let's quickly have a look. Okay, without hopefully not disrupting the flow too much. And they're talking about this. We had 1 is equal to b to the power minus 1 plus p. You can make 1 any variable at all. So if this was c to the power minus 1 plus p, you could certainly make 1 c to the power of 0. You can use absolutely any variable that you like there. All right.
All right, one last more. How do I find the nature of the roots by just looking at the function?
Okay, that's a different section. So we're not tackling that today. Nature of roots is a completely different monster. So we're not looking at nature of roots today, guys. So I'm not even going to tackle that. We need to quickly finish the question we're doing now.
All right.
Okay, so we're going to carry on with the graph interpretation. If you guys have any problems with the question I'm looking at now, please let us know. Okay, we're on to part C. All right, so let's just get that moving. C, we need to find the length from O to C. Okay, and I'm just going to now erase some of the other things I've done on this graph so we can have a look at OC. All right, and OC is from the origin to a point on the exponential graph. Not just any point, a specific point. This is the x-intercept of the exponential graph. So if I know what the value at point C is, if I know what the coordinates are, I can simply subtract the two to find the distance from O to C. All right, so how do we find x-intercepts now? We're looking at the exponential graph. To find your x-intercept, you let y equal to 0. So in the equation 2 to the power x plus 1 minus 4, we let g of x be 0 and solve for x. Again, we're dealing with exponential equations, which you guys did in the first term. So we'll have 2 to the power x plus 1 is equal to 4. I've just taken the negative 4 to the other side. 4 we can rewrite as 2 squared. Guys, remember, whenever you're solving an exponential equation and your unknown is in the power, then you've got to make your bases the same. So therefore, once the bases are the same, we can equate the powers. So therefore, x plus 1 is equal to 2. So therefore, x would be equal to 2 minus 1, which is just 1. So therefore, the coordinates of C are 1 and 0. So the distance from O to C, remember O is the origin, the distance is simply going to be 1 unit. Okay, so it's going to be the distance from 0, 0 to the point 1, 0, which is just simply 1 unit. Okay, and quickly let's have a look at D, which wants us to find the length BC. Okay, so let's have a look. BC is that point just above the x-intercept of the exponential graph. In fact, it's in the same vertical line. So therefore, the x-coordinate at point C is also the x-coordinate at point B. So if I want to find the vertical distance from B to C, I need the y-coordinates at point B. How do I do it? Well, we know that they're in the same perpendicular distance, so therefore the coordinates at C, which was 1, 0, implies that the x-coordinate at point B is 1, okay, because they're on the same, as you can see, they're on the same vertical. So therefore the x-coordinate is 1, and I need to find the y value. All right. Remember, whenever you're looking for vertical distances, you're always dealing with y coordinates. All right, so we know we're using, once again, the parabola. F of x is equal to negative, you can never remember this equation, negative x minus 2 squared plus 4. And guys, it looks like we are running out of time, so I'm going to leave part D for you to do by yourself, but I will give you a hint. Okay, remember, we know that the x value at point C is 1, so therefore the x coordinate at point B is also 1, as I showed you. So we substitute 1 in place of x and we solve for y. All right, so we get minus 1 minus 2 is just negative 1 squared is going to be just 1. So I get 4 minus 1, which is 3. So therefore the coordinates at point B is 1 and 3. Okay, so that's the coordinates at point B. And all we're interested in, because remember we're looking at a vertical distance. So all I want to do, if I want the distance from B to C, is I'm going to look at the distance between the y values. I'm going to subtract the coordinates. 3 minus 0 is going to give me 3 units. So therefore, the distance BC is equal to 3 units. It's just the vertical distance, so it's the difference between the y values on your graph. Okay, so it was just that distance there. And it's only, remember, you don't always do this when you want distances. It's only because these were on the same perpendicular line. All right, quickly, let me give you a hint for part D. Okay, for part E. If you want the distance FG, okay, so look at your graph, and these graphs are up there for you. If you want the distance FG, it's a horizontal distance, guys, but very special. This lies on the line y is equal to -4. It lies on the asymptote of the exponential graph. So you know that all along that line, your y value is equal to -4. All you've got to do is take that -4, substitute it as the y value of your parabola, and then solve for x. And you'll be able to find the distance FG. All right, thank you guys for joining us today. We've covered so much of work, and I hope you've learned a lot.
Well, they've learned a lot. I'm definitely sure about that because the response is just so great. I even have comments from offenses saying, you know what, Natasha is just my best teacher ever. And thank you very much for the great work that you're doing.
Thank you. Thank you.
Yes, Mindsetters, we have come to the end of our show today. Pre-matriculants, I hope you've enjoyed the show. And we just want to say a big thank you to our sponsor of the day, Macmillan. See you some other time. Thank you very much. Keep learning.